Okay, so in my previous video, I showed you how to draw any ray diagram using two rays. We first needed to draw the parallel ray that gets refracted through the focal point. We then needed to draw a ray passing through the center of the lens that goes through completely unrefracted. Now, in this video, I'm going to try to cover all examples of possible scenarios they could throw at you when drawing ray diagrams in the exam. So let's go through example 1. Now, this is going to be when the object distance, so remember u, is less than f. Okay, so let's draw our principal axis. I'm going to draw our convex lens, and instead of drawing the curved surface, I'm just going to represent it with arrows from now on, which is what we will see in the future. So let's draw our focal point F, and now we want to place our object inside one focal length, so that's going to be U. Okay, so that's my object. And I'm just going to label that O for object. Then we're going to draw one parallel ray. Now this, remember, gets refracted through the focal point. Okay, next we draw our second ray. Now this gets refracted, or this passes through the center of the lens and it goes through completely unrefracted. As you can see, these two rays diverge. So we've got rays diverge. Okay, so if you remember from my first video, if not, I recommend going through it again. But virtual images form from the apparent divergence of light rays from a point. So we need to trace back, and we can see that the rays appear to meet at this point here. So this will be where my image I is formed. So my image and my object. Okay, so we can see that we've got a virtual image formed. One, because it's from the apparent divergence, or rays only appear to meet. But we could also tell that it's a virtual image because the image is formed on the same side of the lens as the object. Now, as you do more and more ray tracing examples, this will become clear. It's just a pattern. Okay, we can also see that the image is now enlarged. So it's got bigger. And we can also see that it's upright because the arrowhead is pointed up. So if this was a person, this person would have its head there. So the person would now appear bigger. Okay, so for our second example, I'm just going to move the object back. So my object, we're going to move back. So let's draw our principal axis, our convex lens, focal point, same distance on either side of the lens. Now I'm going to move the object and position it on the focal point. So this is an example when U, so object distance, is equal to focal length. Again, I'm going to draw my parallel ray that gets refracted through the focal point. Then I'm going to draw my ray that goes through the center of the lens, completely unrefracted. Now in this case, what you can see is that the rays are parallel. So even if we trace back, we still never reach a point where the two images, where the two rays meet. So what we get for this example, it's a bit of a special case, is we get an image formed at infinity. I don't want to go into too much detail for this because this is all you need to know for A-level. You just need to know when U is equal to F, we get an image formed at infinity. Okay, so my next example, again, I'm just going to move it back. Now this is going to be when our object distance is greater than the focal length. So same process, principal axis, lens, focal point, focal point. Now see if you can pause the video and have a go, and then play when you're ready to see the answer. So at this point we can place our object at a distance larger than one focal length, so outside. Then we're going to draw our parallel ray. Parallel ray gets refracted through the focal point. We get a second ray that goes through the center of the lens, completely unrefracted. Okay, and this time we can see that the rays do actually meet. So this is going to form the tip of our arrowhead. Okay, if we repeated that process, so parallel ray through the focal point, then a second ray unrefracted, we get that the middle of the arrow will form over here. If we repeat that process a number of times, we get that that image will form over here. Okay, and this time we can see that we've got, well, the light rays do actually meet, so that will tell us that it's a real image. And let's say, so that means it can be projected onto a screen. The image is actually this time inverted because it's upside down, but it's also been enlarged. Okay, so these are the three keywords we need to use when describing any ray diagram. Okay, now again, try and pause the video and have a go at this question for yourself. So example 4. Now this time we're going to have a case when the object distance is larger than 2 focal lengths, so it's more than 2 focal lengths away from the lens. So try and pause the video. So that's going to be my 1 focal length, and then roughly that's my 2nd focal length. Now in the exam you want to be using a ruler and measuring these distances accurately. Okay, so now let's place my object more than 2 focal lengths away. Now I'm going to repeat exactly the same process. So I'm going to have my parallel ray that goes through. Now again, even though it's over 2 focal lengths, it's still going to get refracted through the focal length of the lens. Now again, we're going to use our central ray. It goes through the center of the lens, completely unrefracted. Where the 2 rays meet is where my object will form. That's my tip. So that's where the object gets formed. Now in this case, again, the light rays do actually meet because they do actually cross. We didn't have to trace back. So we can then say that that's going to be a real image. We can see that it's inverted, so it's upside down. And this time, if you measured it accurately, you'd find that it's actually diminished. So in other words, it's got smaller. So when you place the object at a distance greater than 2 focal lengths, you get a diminished object. Whereas before, when we placed it just greater than 1 focal length, but less than 2 focal lengths, we can see that it was actually enlarged. So we've got a different effect. Now for my final example, now this is something that's less likely to come up, but it's worth understanding. If I draw, again I draw my lens. Now this time, let's say we've got rays all coming from infinity. Okay, so again, it's not too important to understand the details of this. Just understand how to draw the ray diagram. Okay, and let's say we've got one on the principal axis. Well, first of all, we know the one on the principal axis this time is going to go through completely unrefracted because it goes through the center of the lens. Now, if the focal length of the lens is here, every single light ray is going to pass through that focal length. So let's draw that in. Even the ones below the principal axis. So as you can see, we get that our image is formed at the focal point. So we get image formed at focal point. Okay, so to summarize, we can say that all convex lenses, so convex lens, they can form real or virtual images. So remember my example, my first example, we had in fact a virtual image formed where the image was enlarged. Now in another example we had where the image was diminished. So the image can be enlarged or diminished. And it can also be it can also be inverted or upright. So upright or inverted. Okay, so let's try to remember those three things. We can have any sort of scenario for a convex lens. In my next video, I'm going to go on to concave lenses.